Welcome to the YouTube channel of the ParisDeno meetup. My name is Denoemie. I'm the robot voice of ParisDeno. ParisDeno is the first French and Parisian meetup focusing on the Deno technology. The meetup is organized about every 2 months, at the beginning of the month, and we usually plan the event 1 to 2 weeks before. The format can be regular or physical, like any classic meetup, but we also sometimes do an online format with a stream on YouTube. For more information, you can find us on the following social networks: LinkedIn, Discord, meetup.com, and of course, YouTube. You can also contact us directly on Twitter or at the email address contact@deno.paris. We will be happy to answer your questions. Of course, we are constantly looking for speakers. The proposed topics can be of any kind, such as, for example, personal or professional feedback, the presentation of a library or a framework, the use of Deno-specific features, and so on. The meetup and talks are inclusive, beginner-friendly, and if you've never had the opportunity to make your first presentation, you can still get started. It's even highly recommended. Don't hesitate. Apart from the classic 20 to 30-minute talks, the length and format can vary if you want, ranging from 5 minutes lightning talk to 1-hour workshop sessions. Finally, we have a GitHub repository where you can submit your abstracts. Even if my voice sounds emotionless, we would also like to warmly thank Paris TypeScript, our meetup partner. If you are interested in TypeScript beyond Deno, go to typescript.paris to find an active community on the subject. Sorry about my robotic presentation, but you prefer my accent, believe me. So, once again, on behalf of the ParisDeno team, welcome to the channel.
Hello, everyone.
Hello.
So we are back again for this second session. So tonight your MC will be Sylvain. So because I will have a talk, so I let him speak.
Yep. So on the program tonight, 3 talks. So we're gonna start with Lilian. He will give you an introduction to Deno. After that, we have Nicolas. We will give you an overview of the modules and how to support all platforms. And also, he will give us feedback on the work he did on this topic in the Fast Check project. And finally, we have Joseph. He will tell you about Denoify, a tool for NPM package authors to get a Deno-compatible version of the sources. So during the talk, do not hesitate to ask your question using the question tag. And at the end of each talk, I will ask them to the speaker for you. So now let's get started with Lilian and have a good meetup.
Thank you. So, share my screen. So, introduction to Deno. So maybe there is some of you that don't know Deno, and last time I did not have the time to do this presentation, but I think when you start a meetup about a new technology, it's good to do a talk to introduce this technology. So this is the purpose of this presentation. So Deno, why, when, and how. So my name is Lilian. I'm the creator of ParisDeno. I'm a software architect at Wind, and you can contact me either with the mail address or on Twitter. So introduction. So Deno was introduced by Ryan Dell, the creator of Node.js, in June 2019 at the JSConf, where he exposed 10 problems in Node.js. these 10 problems, you know that they start very early at the beginning of Node.js, and Node.js did not get out of the path of these problems, and they are still there in the current version of Node.js. Node.js is currently evolving. Some of them maybe disappear in the future, but most of them are still there. So that's why he wanted to build something new, brand new, from scratch, without this kind of problem. You can flash the QR code, and there will be a link direct to the video of the JSConf of the presentation of Ryan. So quick follow-up about the training. Since the creation of Denoemie versus Node.js, this month Deno gained 14,000 stars, which is huge, and is the first repository, first training repository on Github for this month. And as you can see in the graph, the growth is very, very, very important, and maybe in the near future it'll be maybe higher than Node.js. So Node versus Deno. So this is not like a comparison to which one is better. This is a comparison about the problem found by Ryan in Node, and how Deno is trying to resolve them. So first of all, the callback. Node is callback based, which means that I think for most of you that develop in Node.js, you know that there is a lot of function with callback, and with the time, the Node didn't really get far from that, and only since 1 or 2 years, I think we have the Promisify utility. But it's a utility that transforms callback into promise, but this is not promise based in the core level. So Deno try to resolve that, and is promise based, and support the top level await, which means that you can have the promise at the very beginning of your application, and not a stub function mix up with like a fire and forget await, fire and forget promise in your script. No security, which means that in Node.js you can access file system and network without any complaint of the user or the OS. But it's not the case in Deno, where you have a security flag like Allonet, for example, which means that the user will not be surprised by any access of any kind of resources in his application when he executes a Deno application. Binding with Jeep, so maybe I pronounce bad, but generate your project is the tool used to make the binding between V8, sorry, and your Node.js. This is something tool built in C++, and very heavy stuff, very complicated. So Deno does not support a Jeep. He has his own type of binding, because Rust is built with Rust, and he uses Rusty V8 to handle all the binding. Rusty V8 is more flexible and more easy to use, depending of your skills with Rust, obviously. One particular fail of Node, and it's totally my opinion, is NPM, which leads to a graph of dependency and the handling of dependency that is very too heavy. Since the years, this handling has not been better with the time. So in Deno, you have no dependency manager, and it's an import with a direct URL from your source. So, for example, if you have a source on GitHub, on the raw GitHub file, you can direct import the HTTP URL in your code. No file extension on import and the handling of index.js. The problem with that is that it's not web compatible. Is not following the web standard, which means that when you call a file, with the extension, you have not assumption of which extension to use. So Deno have the prerogative to use an explicit file extension, and you do not have a default file configuration. For example, in Node.js, you have index.js, who can be your default file in a folder. It's not the case in Deno. Even if you have the convention of the mod.ts, this is not the default file. This is just a convention. The require. So the require is the way to import module in your Node code, and it's very complicated. The algorithm behind that is very hairy, I would say, and it leads to some of security issues and also performance issues, because it's searching over all your folder, and it's very heavy stuff. So, and also it's not web compatible. And Deno is not the case. Deno, you have the import style. You will see more in the next 2 talks, but import style is a standard for the web that is currently adopted natively in the browser, and this is the standard way to import module in Deno. Node is not web compatible, which means that it's not also isomorphic. You do not have the window object on the root of Node.js. So okay, Node is not made for browser, but when you want to make an isomorphic library, because it's the same language in a front and a backend application, it's more difficult because you don't have the same environment. In Deno, it's more easy because you have the window object, and you also have, for example, the event the event function for load and unload that you have on a window. And finally, Node is still alive after a non-code error on premises. You have a warning for now, which means that in the near future this will be solved. So that's why I put it in the last. But it's still the case, and on contrary, Deno dies after a non-code error on any kind of promise, which means that if you don't have a catch on your promise, or you have a try catch around the promise, your application will fail and close with a code error 1 if you did not catch it. The feature. So I will present you now the main feature of the big feature of Deno. So first you have what I want to call the core. The core of Deno is that you have a security flag, like I said before. That kind of flag helps you to have a better secured environment, and this flag can help you access to env, @time, net, how to load a plugin, read a file, run a sub-process, or write a file. You can also hide whitelist for the net and file system access, which means that you can, for example, say I had the security flag for the net, but only for the Google domain, for example. And file system, it's close to be the same case, but you can specify only one folder, for example. Deno support TypeScript out of the box, which means that you do not have to care about a TS config or a Webpack or Browserify, or I don't know. You can directly type in TypeScript and use the Deno definition directly in your code. Deno is also WebAssembly compatible, which means that directly in your application, you can import a WebAssembly file or add a WebAssembly binary in a uint array, for example, and load it directly in your Deno application. Finally, Deno is built as one executable file, which means that when you install Deno, you have only one executable file, and that's all. And this is the single entry point that you will use when you execute a Deno application, for example. So the runtime features, you have in Deno an unstable flag, which means that Deno, since the 1.0, aim to be stable, production ready, and all the stuff that is currently tested or currently stabilized, is behind the unstable flag, and you should be aware that it's willing to change in the near future, or maybe there is some bug fix to do or some test to add before having the feature stable again. Like I said before, you have the load and unload lifecycle method that you can find on the window object. You also have a compiler API, which means that directly in the code, you have access to the compiler API, and you can have the possibility to build a Deno application or even a TS file on the fly, for example, or just transpile or whatever. This can be used, for example, to do another type of linter or another webpack in Deno. I don't know. There is much possibilities. And finally, the worker. Deno is compatible with worker, which means that it's the same type of worker that you can find in your browser. To use a worker, because you point to another file, another .ts file, you need to have allow read or net if you use a third-party TS file or a distant TS file. And it's pure web by default, but when you load your worker, you can specify a property Deno true to set worker Deno compatible, but be aware that it will not be web compatible anymore because you use the Deno stuff. The dependencies. So the dependencies are cached and centralized in the Deno dir, which means that similarly to Yarn plug and play, you have a centralized repository where all the files used for the Deno compilation are allocated. There is no node modules or equivalents in your repository, so each of your project will use the same repository. If you want to lock your version, you can use the log file with the flag lock on your application. This will generate a .json that use the SHA-1 of the commit, if I remember right. When you use a file from the net, I don't remember if it's the SHA-1 or something else. Anyway, you have also the depth.ts convention. Sometimes when you use when you have a big code base, it's better to use some depth.ts convention that will act like a barrel, for example, and will centralize all your dependency in your application. It will help you to upgrade your version, for example, if you use a multiple standard of Deno and you want to bump all the version with the latest or something like that. You can also add an import map in your application, like in the web browser. The import map will help you to, like for example, alias in Webpack will help you to have short names in your import string when you do an import. For example, you can hide all the std, like I show you under the Denolan std. You can hide it behind just std string. And finally, Node.js polyfile that should be used only for migration. That is under std. Finally, this is a full, no, not totally full, but an attempt to polyfile all the API that you find in Node. This will help some major library to be ported in Deno, for example. If you have because of the file system access is different in Deno and Node.js, so that's why. But keep in mind that is for migration only and should not be used for straight in your application. Try to use as much as possible the STD and only the STD without Node.js. And finally, the tooling. Deno come with an opinionated CLI with all-in-one tool that have a format like Prettier, but now it's based on a dprint. Dprint is a tool like Prettier, but written in Rust. Deno bundle will help you to bundle your TS files in one single JS file to be run later with Deno, for example. Deno install will help you, for example, if you have a full application with an entry point, you can install, for example, on GitHub, for example, you can install it and specify the GitHub link, and it will be installed as bin in your bin pass directory, which means that you can have direct access in your command line interface. Deno doc will help you to generate a doc for your application. And finally, Deno info will help you have an inspection of your dependency graph of your application. For now, you don't have a lot of dependency graph, but later it will help some people to not repeat the mistake of the npm and non-module heavy stuff, because it's not because you don't have the non-module locally that you cannot have a messy dependency graph. And also on the tooling, you have a debugger that is included in Deno with the flag inspect and inspect brk, sorry. So the debugger is used almost like the node debugger, and will pop a Chrome debugger that you can plug with your VS Code to help you debug your application. Very basic stuff. So now I will show you some example of Deno code, like 3 example that are, in my opinion, a very good representation of what Deno is capable of. So the first example is, I hope that the Zoom is okay for everyone. So the first example is a grep, a basic grep that I made. So the goal of this application is basic, is to represent the grep. So you have a file. You put this. So now it's caching all the dependency, and the command was this: it find the string foo on the file that we had. So what does it do? So you have the depths, like I mentioned before. The depths is grouping all my dependency in one file. So if I need to change or specify a version, I can set up in there. And I have my mod.ts that try to analyze the arguments. So for example, if I don't give the file, I put the .r. If I don't give a file, it will throw me an error, missing arguments. Yes. And after that is very, very standard TypeScript. The part that is interesting is this one, the text decoder, the read file, sorry, with the text decoder. So the text decoder, you can find it in a website, in the front side. But how to read file, like I said before, it's not a FS read file, it's the Deno read file. So this is an await. This is not a callback. You get the content, which is an int array. You decode it, and you get all the files, all the lines, sorry. And yeah, this is a very basic stuff. So the second one is an example of how to use Deno with external library, and particularly React, for example. So this one, the guess a number, is an application very, I won't say easy. It's it get a number internally, a random number, and you can guess if the number you can give numbers, and it will tell you if the solution is higher or lower than your suggestion. So my explanation is very bad, so I will give you a demonstration. Hook. So with this application, we use Hawk, which is like a Koa or Express, but in Deno, to set up our server. We have the TS6 that use a React DOM server internally to generate our page, and here it's just the configuration of my application, very standard TypeScript. Sure. Okay. Okay. This is an epic fail. Okay, so sorry about that. I thought I would be working. This is a demo effect, obviously. Okay. Oh, my bad. So the interesting part is this one. I will not explain a lot about what is happening here. You will have more information on the second talk. But basically, we use Pika to load our React application. We use the Deno type to have the type of React and the type of JSX. And we do the same for DOM. And you can use JSX as is without any tsconfig application. With tsconfig configuration, and voila, I want to say. And the last that will not work yet because Vercel is not yet compatible with Deno 1.03 and only 1.02 for now. So you can set up a Lambda now on Vercel with Deno, because you have the runtime now Deno. And if you already did Lambda on AWS with Node, it's close to the same. So here is a basic Lambda that I made that get the context and my request. And when the Lambda is called, I return a result with a body and basic headers. These headers, I go to the page, I get the page, and same as before, I use React and React DOM to generate a basic page that will show my Vercel plus Deno plus React DOM server. But obviously, demo effect, this is not working also because of Vercel. But yeah, as you can see in my repository, I only have my Lambda and just one basic config file for now, and you can very easily deploy your application like that. So yeah, that's all for me. Thank you, guys.
Thank you, Lilian. So we have two questions in the chat. So the first one is from Nicolas. So you are in the in the stream, so probably you can ask that by yourself.
Yes. So how to get type definition in VS Code when using Deno? Is there a built-in support? Ah, yes. Thank you. So currently there is an extension that is developed by just Javac. So previously there was an extension by Xtroy, but why? Oh, the extension is not. Please. Okay. So yes, you have an official extension now. As you can see, you have an official extension on the marketplace, and I suggest you to use this one, but it's still in development. And for example, Xtroy extension, I have some of the features that the official extension have not. For example, the format on save, format on past, the support of JSX, and not the support of JSX, but the support of certain type imported by the Deno types. So use this extension, and after that you have the Deno type for Deno types / command that you can use to import local or external definition type to enhance your application if you use a PCAR or GSPM or stuff like that.
Okay. So next question from Alvard. Do you have a repository and the React example is available?
Yes.
Probably
so
yes.
Yes, this is this one intro.
Yep. So you can share we will share the link in the chat. And also, is it possible to bundle a React application with Deno? So we had a demonstration during the first event about that.
Say yes. So this is
the answer is yes.
Yes, you can see the talk of Yacine on
Yep.
the first ParisDeno, and but for example, in my application here, the React and React DOM server. Okay, this is server side, but this is bundled in one application to be executed in the Lambda side, and these use a Deno bundle internally. So my application will be used like that. But you can for front end side, you can see the talk of Yacine on the first ParisDeno meetup.
And it was a great one.
Yeah.
So with all the information about this topic.
Oh.
So I will share a link in the chat for everybody. We don't have other questions.
So this is one. Okay. Yep. But thank you guys. And if you have any later question, don't hesitate to ask me on Twitter or on the repository or whatever.
Thanks, Lilian.
Yes, thank you guys.
So now it's time for Nicolas to share with us everything about modules.
Okay, I'm just sharing my screen. Can you hear me? Is that working fine?
We can hear you.
Okay. So you should be able to see my screen.
It's okay.
Okay. So thanks a lot, ParisDeno, for this meetup. And today I want to talk about how you can bundle a package for Deno, CommonJS, and ECMAScript module all together. My name is Nicolas, and you can find me on my Twitter, on my GitHub, and I'm working a project called FastCheck. But let's move on. So before we go about how we can bundle packages for several platforms, let's first of all consider what have been modules over the time. So everything started in 1991 when World Wide Web came up, and at that time there were only static web pages, and JavaScript born in 1995. So between 1991 and 1995, everything was static website. Web 1.0 looked something like this one. So basically, you had to import manually all your scripts and everything was loaded synchronously. So if you want to have something from A in B, you need to load A first and then B. And if you want to access some kind of DOM element, you need to render the DOM elements first and then load your script. That's the case for C.js, for instance. And so everything was, let's say, synchronous because you had to declare it was in the order it came in the file, and there was no built-in way to deal with dependencies. Then Node.js came up, and it has been released in 2009, and it comes up with a way to natively deal with dependencies, and this way to deal with dependencies was called CommonJS. CommonJS looked like this stuff. So basically in CommonJS, you have to require file without the extension. So you can call it whatever you want. For, in my case, I call it module A. And if you want to export some stuff, so if you want to create your own module, you can export stuff that will be visible by your users. In my case, I'm exporting two properties, A and B. But there were no real way to deal with dependencies by that time in the browser. Actually, there was some kind of stuff like Dojo Loader in 2004, Require.js in 2010, and Curl.js in 2011. Dates might be, we might have some errors in the dates, but just to give you some ideas of the dates. And what is important is that the asynchronous module definition, which often referred as AMD, in when you configure your TS config, you can define AMD, for instance, as the output. It has been specified in 2011. So before that time, there was no real specification in the browser to deal with dependencies. And AMD looks that way. So basically, your AMD loader will export some kind of function called define. So it's exported by Require.js, it's exported by Curl.js, it's exported by Dojo Loader, for instance. And using this function, you may define dependencies. So basically, in this case, I'm defining two dependencies, dependency 1 and dependency 2. And as soon as they get loaded, I will be called on this function, and I can define my own module. So basically, it was a way to define modules in the web. So let's first of all summarize what we've seen so far. So basically, we had two ways to load modules. One which is server-side with CommonJS and Node, and another one which was more browser-oriented with AMD. So in case in the imports has to be done a bit differently. So in one case, we do some require. In the other case, we use some kind of function called define. In terms of export, we just have to do export.value for CommonJS, and we have to return a basic object for AMD. Something which is a bit different is that in terms of synchronicity, so basically in CommonJS, everything will be loaded sequentially. In AMD, it's basically asynchronously because all your dependencies will be loaded all together. And in terms of execution, it has an impact. So basically, for CommonJS, your dependencies will be loaded one at a time. And so dependency A will be loaded first and executed first, then dependency B will be loaded second and executed second. In the case of AMD, it's a bit different. It depends on which one is resolving first. So you don't have any certainty about which one will be executed first. Another difference is that in the case of CommonJS, you can use require wherever you want in your application. So basically, you can call require within functions. You can call require at the top of your file. You can call require at the end of the file. In the case of AMD, you always have to call the definition of your dependencies before you load anything. And in both cases, you don't have anything regarding extensions. So in order to some kind of unify those two ways to deal with module definition, in 2015, ES Modules has been introduced by ECMAScript standards, and it has the syntax is, I think most of people know this syntax. So basically, you can import some stuff from something. You have to specify the extension, and then you can export some constants if you want to. If we take back our table of the previous slide, so basically, if we compare all of those methods together, in the case of ES modules, we want to deal with all kind of modules from browsers to server side. So we cannot have something which is synchronous. we have to deal with asynchronous stuff. In terms of execution, it's a bit the same. It depends because module will be loaded all together and they might be executed in out of order. There is no certainty about when they will be executed. Moreover, if you use top-level await, you may have this kind of asynchronicity even if in the server side. Concerning where to put the import, so basically most of the time it will come at the beginning of your file if you use the import from syntax. Otherwise, you have some kind of helper function which is called just import, which is in that case a function, and it looks a bit like what we did with require. But for the aim of this topic today, we will focus on import from stuff, and import from stuff is basically has to be put at the top of your file. And the main differences between all of those syntaxes is that for ES modules, you have to define the extension of your file. And what about Deno? So as Lilian said, Deno is working with modules. So everything works like in modules. You just have to specify the extension. And in the case of Deno, you work with TypeScript, so extension has to be TS. Before we move on, let me quickly introduce myself. My name is Nicolas. I'm working for a small startup company called Pigment. And you may find me on Github at Dubs or Dubien on Twitter. Today, the topic is to talk a bit about how we can bundle the same package to be compatible with several targets. And why this topic? Because I had the very same issue with FastCheck, which is basically a project I'm working on, which is an open source project. And I had the issue in FastCheck because I wanted my users to be able to use it from legacy version of Node to modern version of Node, including bundlers and including maybe Deno and other stuff. So let's see together how we can do to have TypeScript projects compatible with all those targets together. So let's see how we can do to have something compatible with ES modules. In order to do that, we will consider a very, very simple library. It will be called mylib. Mylib is composed of a single main.ts file, at least for the moment, and it exports some kind of function called callMe. And the function is just saying, okay, hello ParisDeno. First of all, we want our library to be compatible with CommonJS. By CommonJS, I mean that I want some legacy users of Node to be able to require this library and to use it directly. In order to, they should be able to call the function callMe. So in order to do that, our user will have to do some require from mylib, and they may define the type CommonJS in the package.json. It's an optional flag. By default, everything is of type CommonJS in Node. And basically, this is how our user will call our library, or at least how we want our user to call our library. In order to do so, we'll first have to define the tsconfig.json file. In our case, I just remind you that the source file is in src main.ts. What we have to do in order to define our tsconfig is first of all to define the output type. So in our case, we want to output for CommonJS. So I ask TypeScript to build something for CommonJS. Then we will have to define where is the output of the build. So basically everything coming from source will be put into build. Now that we have defined our tsconfig, we can now move on and define the package.json. The package.json will be used by our users to know where to find the files. So basically, our users will have two main informations to look into. So basically, the type of the package. So in our case, the package is a CommonJS one. So I want to explicitly set the type to CommonJS. Once again, it's optional because by default, everything is CommonJS in Node, even in recent version of Node. Then I want to define where is the main script. So the main script is basically what you will get when you do require from mylib. Every time someone will require something from mylib, it will get data coming from build.main.js. And the last thing to do is basically to call the build script TSC. So that's pretty neat. People are able to import our script, and they should be able to use our lib using CommonJS. But I want also to support TypeScript users. So in order to support TypeScript users, I will first of all need to output type declarations. So in order to do that, I will edit my TS config, the one we had before, and add this line. So basically, I'm asking to TypeScript to generate declarations. Then I will need to tell TypeScript where to find those declarations. So it's basically something that will be used by the users. So basically, every time someone will load my package, if they are using TypeScript, TypeScript will use this types field in order to know where to find the typing. So with that, we will easily support TypeScript users. So it's pretty cool. We are now able to deal with CommonJS users and also TypeScript users. But I want my library to be a bit more open to other users. So first of all, I want to support browsers. So by browsers, I mean I want people using legacy way to import script to be able to load my script. So basically, I want people using GSDeliver, for instance, to be able to load my lib. And as soon as the lib has been loaded by this script statement, they should be able to use it directly. So we have two options for that part. So either we do some kind of specific build for the web users, or we can go for ES modules. In that case, I will just go for the first option. We will see later how we can deal with the ES module stuff. But I prefer to go for the first step first, because we will have some kind of specific bundle for the web users, something which might be minified and stuff like that in a single JS file. How do we do that? So we take back our package.json and we will update it. We first of all load another dependencies, which is called browserify. We define a build step, which will be called web build. So web build is just taking the output of TypeScript, so build.main, build/main.js, and it will generate a file called gen.js, basically. And now we can define browser that will be understandable by most of bundlers if we want to. Now we are able to, so our web users will simply be able to load our script if they want to, as we've seen before. But what about rollups, webpacks, and other modern bundlers? Out of the box, they have been able to deal with ES modules for a while, even before Node came with the support for ES modules. And in order to do that, they introduced a specific field in the package.json, which is called module. So let's see how we can be able to support them easily. So once again, we take back our package.json file, and we'll do several changes. These are the two changes we'll do. So first of all, we declare another field which is called module. And the module field will be used by bundlers in order to know where to find the ECMAScript module build of our library. It's pretty useful to have this kind of setting, because bundler will be able to do some kind of tree shaking and stuff like that around libraries that have been provided using module flag. So ECMAScript modules can be very useful if you want to have tree shaking, mostly for web apps and stuff like that. It would be pretty useful, I think. And you need to, in order to support them, you also need to have a specific build, because the first build we've done so far, the build we had so far was only outputting some kind of CommonJS, but we want to be able to output ECMAScript modules. So in order to do that, we just add another line for TypeScript. And we ask TypeScript to generate ES next version of the module and to output the data into build/ESM. With that two line of code, we are now able to deal with ECMAScript modules for bundlers. But what about ECMAScript modules for Node? Actually, everything should already be ready, but Node has not taken the same direction and the same path as what bundlers did before. So first of all, Node is not using module because they are not using module. And something else is that Node doesn't want to mix modules and CommonJS. So you cannot have the same package dealing with both module and CommonJS. Actually, you can more or less, but we'll see together how we can do that. And then there is another issue. It's basically that TypeScript out of the box doesn't properly transpile file to ECMAScript compatible version of the modules. So let's see that first of all. So let's imagine that our main.ts was this one. So basically we import call.me from another TypeScript file, which is called A, and we export call.me. The output of TypeScript with the ECMAScript flag will be something like that. So we will just import from A and export to A. But there is an issue because this transpiled version is actually not compatible with ECMAScript because it's missing the extension of the A file in that line. Basically, what we should have is something like that. We can basically, in TypeScript, you can basically import everything by adding the extension .js, but in my opinion, it doesn't look neat. It doesn't look pretty to do imports with .js when you want to import the TS file. But you can actually fix your bug, the bug just by adding .js extension everywhere in your TS file, and it will work. So, but let's see how we can do if we want to fully support ECMAScript modules in our library. So once again, we'll have to update our package.json. This time, we will do a first thing. So first of all, I want to add the extension because out of the box, TypeScript is not able to put the extension for me. So I just defining another step in my script, which will be called build ESM post, and it will basically just add the extensions. Just to let you know how the scripts look like, it's basically replacing file and adding the .js extension everywhere. The script is not the best one ever, but it does the job, and it's pretty cool if it does the job. So now everything is good because we are able to, we automatically build ES file ECMAScript modules compatible for Node actually. But we still have an issue because Node does not allow us to support both CommonJS and modules all together in the same package. So we'll need to do some kind of trick in order to have it working. So we'll take back again our package.json. And we'll add an additional section which is called exports. So this is a recent feature of Node. You can define specific exports. So by defining exports, you can say that in case of require, I want to use the build for CommonJS. And in case of default, which is basically import the ES module stuff, I want to use the ECMAScript modules definition of the JS file. And I'm still using the main to be the CommonJS. So if you have a look at line 4 of my code, you can see that the main is still the same. It's still referencing the CommonJS part. So basically, my package is still a CommonJS package, but it has an exports part that will be that can override part of this statement. And we need to add another thing, which is just telling Node that the path build ESM is always a module. So we just have to define a package.json with only type module in order to support module for this part of the path. So now everything should be okay, and we should be able to load our library from CommonJS to ECMAScript modules to bundler to browsers and stuff like that. But what about Deno? In the case of Deno, let's just first of all consider this very simple main.ts file. So this one is a classical TypeScript file targeting Node in general. So basically, I'm importing something from another lib, which is a lib I have imported in my npm definition. And then I'm also importing stuff from /a, which is one of my files. But actually, in Deno, I should have something like that. So first of all, the other library should have been imported using some kind of URL. And in the case of the /a file, I should also include the extension .ts. And there are two problems there. So first of all, TypeScript, the one you may use in npm, doesn't support URLs at all. And in TypeScript, actually, you cannot import using .ts extension. So TypeScript will not be OK if you use .ts extension. So it's not so easy to do that, but I found a trick for fast check. So basically, I just had to rely on cdn pk.dev. And knowing that the package is already compatible with ECMAScript modules, I just have to import my library using the CDN provided by Pika, and I'm able to just basically use my library within Deno. So I think that was the only trick I had to do for Deno. It's still a partial support because it's rely on an external CDN, but it does the job today to just import the library, and with the typing, we can import the typings with the @Deno types. I think Lilian had this tag before in the presentation. And that's all for the presentation. If you have questions, feel free.
Thanks, Nicolas. Let's wait a couple of seconds. So the conclusion is that Pika is amazing.
Yes.
Probably this is the conclusion.
At least he did the job for this part.
Yeah, this is really a great tool.
I think the conclusion is that with the support of ECMAScript modules for Node, you are already able to deal with Deno if you want to. But more or less, I've never used Deno more than that, so maybe I still have some troubles with that. But
yeah. Okay, so no question. Maybe we can continue with Joseph.
Okay.
And Denoify.
Yes.
And if you have question after that, probably we will answer that in the chat.
Une fenêtre ou un écran. Okay. Can everyone see my slides?
It's loading. Okay, seems, yep.
Okay, right.
Perfect.
Okay, so hello everyone. Thank you to Lilian and Sylvain for giving me this opportunity to present my work today. I'm very excited. The tool I'm working on is something that is solving the same problem that we addressed before, which is to target both Node and Deno and other platform with a single code base. But I address it in a different way using a build tool that I call Denoify. And it's unable to support, to bring support, first-class citizen support to Deno for NPM module, and doing so without introducing any breaking changes. And it's only a one-time cost to set it up. So first, a word about me. I'm Joseph Garrone. I studied applied mathematics at NCMAG Grenoble, then computer engineering at the Polytechnic University of Turin. Then I founded Semasim, which is a small telecom company. And all the code we do is in TypeScript. And I'm also very much involved in open source. I love types and code that can run everywhere. So I'm involved in making code run on React Native, Node, browsers, and today Deno, which is the subject of my talk. So you can see an example here of the kind of work that Denoify does. So Denoify is a build tool that take as input a TypeScript code base that was meant to target Node or the web, and spit out a modified version of the source files that are ready to be deployed as a Deno module. So you can see in this example, for example, I'm using NPM module TS MD5. I'm using the file system node module built-in, and I'm using also dirname, which is a global in Node, and Denoify spit out this modified version of these source files that does run on Deno. You can see that it produces exactly the same output. So it has some different use case with the CommonJS module loader that you may know, which is the default tool to load npm module into your Deno application. The CommonJS module loader requires you to have a node module directory sitting around, and we don't want that. It does not import the types, and it requires you to grant read access to Deno.
Joseph,
Oui.
just a quick question for you, but do you share the right screen because we are on the proof of concept page? Is it the right one, just to be sure?
No, it's not the right one. It's not the right one. All right. Okay. I see what happened. So I can't. Okay, I will do my presentation here. So with the editor, unfortunately. So this was the thing I was talking about. So you didn't saw this, right?
Yep.
Okay, so this is the script that Denoify output by replacing import by URLs and by polyfiling some of the Node API. You can see that. So it is different from the CommonJS module loader. But to be fair, the CommonJS module loader is also much easier to set up. Denoify is more for npm module authors that want to bring support to Deno.
It seems that your presentation still lock on the proof of concept page. Everybody just saw this page, and I don't think you are talking about that currently.
No. I'm
just
sorry.
no.
I'm sorry. I think. Okay. This is embarrassing. Stop presentation.
No.
I will start over again.
Yep. Take your time. It's better if you fix that for everybody.
You want
so
to
take your time.
Okay, I will start.
We had the same problem during the previous ParisType script, so don't worry.
Okay, I feel much better. Okay.
Yes, I see Denoify.
And now, do you see the slide, the green slide? Do you see?
Yes.
Okay, it's what better. Sorry. So it's
without
visual support, it's very hard to follow what I'm talking about. But I leave you some time to look at this slide, because this is the big deal about Denoify. It's that it transforms this node code into this Deno ready code. So yeah, it replaces URL, it's polyfile dir name, and it's find port for TSMD5 to load in Deno. So yeah, that's it. So I see many motivation to work on such a tool. The first motivation is I believe that there's a lot of great npm module that would be a great asset to Deno. I don't think that every npm module should be ported to Deno. I think there are a lot of modules that were designed a decade ago and that are not relevant today, but we should port at least some of them. I believe that from npm author point of view, it would be great not having to choose if I want to target Node or Deno, and it would prevent the JavaScript community from being more divided that it already is. And third, and this is the more important point for me, I think to really take off, Deno need support for the big companies' library, such as Google, Amazon, Apple, Stripe, PayPal. And they have absolutely no incentive to bring that support if we don't make it that easy for them to do so. So Denoify try to address that saying, hey guys, you can just run Denoify on your existing lib and you will bring support. So a proof of concept. Before I should say a word about the limitation. Full disclosure, Denoify is still very much work in progress. It has limitation, first of them being the incomplete support of the Node built-in API. You can check the full list of the requirements that you would need to comply with to get your module compatible with Denoify. But for now, let's focus on what Denoify can do today. And for that, I introduce EVT. EVT, it's another open source project of mine. It's a RxJS-ish library that focus on making the most of TypeScript inference features. And it has been made fully cross-compatible using Denoify. You can find it on NPM, and you can also find it on Denoland. And if you run it, you will have exactly the same user experience on Deno and on the other runtimes. You will get the types and everything. I really encourage you to try and Denoify stuff yourself, because what have been done with EVT can be done with thousands of other modules. So sorry about that. Out again. So let's talk about the technical point now and how Denoify works. So basically what it does, it takes one after the other every source files of your code base and try to replace the import. When it runs against an import that is not importing a local file, but that is importing a dependency, it will try to replace this import with a Deno port of this dependency. So to work, a Denoify need to know a port for each of your dependency. And but bear with me, it's not as bad as it sounds. There is 3 ways you can go about it. The first way is the naive solution of writing a partial port of your dependencies. You don't need to port the whole thing, just rewrite for Deno the part that your module need to be running. I don't like this solution very much because it's very time consuming and it opens the gate to inconsistencies in the way your library will behave on Deno compared to other runtimes. So the second solution, and this is what I'm excited about, is to use Denoify recursively. If you only use Denoified modules such as EVT as dependencies, everything will work out of the box. So you will tell me, but how many of those so-called Denoified modules are there out there? Maybe 3, 4, and it's true, there's very few still, but nothing is stopping you from Denoifying your dependencies yourself. For that, you just have to go and fork the repo, set up Denoify, and use this fork instead in your dependency, in your package JSON dependency list. If this dependency has in turn dependency, you can do that recursively until you reach only dependency-less modules. And I know that in some cases, it might not be feasible depending on how deep the trees goes, but it will work always. And for those who have a tree that is too deep, I have a third solution, which is to rely on the community. In the first months, at least, I will be monitoring the package that people are Denoifying, and I will be adding them to a non-port database that Denoify is consuming. So when someone denoifies something, like for example, the next good candidate could be React, to denoify React, and you could import React with the type definition from denoland/x without having to have a special import for importing type, without having to rely on Pika. So the next person that denoify React, I could add it to this and it would denoify it for him, but also for everyone else. And I believe that with this model, we could reach a point where most commonly used NPM modules are present in this list. And this would mean that most modules will work out of the box with Denoify. And we could denoify most of the module, everything. So the next question is how to publish. Now that you have your distribution files output from Denoify, how do you publish it on the official Deno third-party repo, which is denoland/x? Well, you have two ways to go about it. The naive way, the manual way, is just to track every output of Denoify on your master branch. And these outputs are a Deno dist folder and a mod.ts file at the root of your directory. And you also have to remember every time you hit npm publish to publish a new version to create a new GitHub release. And if you do that, that's it. Your repository is ready to be submitted as a Deno module. But this solution have some drawbacks. First being that I don't like to have a lot of distribution files tracked on my main branch. And it involves, if your users want to import specific path and not the mod.ts index, the path will include Deno dist, which is not very sexy. So I created CI setup for module using Denoify. It does everything, every task related to the life cycle of your project, like redacting a README on how to import your file on different runtimes, testing automatically on multiple versions of Node and Deno on remote containers, and also it will automatically publish for you on npm and Deno every time you push code and you have updated your package.json version number. So it's a really cool tool. It does linting as well. It uses Prettyfire. So all you have many reasons why you might want to get involved in this project. First, we need your help to finish the polyfile of the Node API in Deno. I believe that it's in the Deno maintainers to-do list to do that, but this is what Denoify is using behind the hood, to behind the scene to convert the Node API calls. So you may want to do part of it yourself for three reasons. First is that it will make your Node module supported faster because you can target the missing features. If you're missing, for example, I don't know, the HTTP module, you can do it and get your library supported. You will also get your name in the official, it will make you a Deno contributor, as a matter of fact. And the third point is that it is a very fun way to understand more about Deno and how it works compared to Node. So to get started, you just have to grab the @type./node definitions, and you can start polyfiling the API from there. So thank you very much for your attention. Sorry about the technical issues. If you have any questions, I will be, or if you need assistance to set up Denoify on your projects, I will be really happy to help you. You can reach me on GitHub or on Twitter or even on Reddit. And that's it for me. Thank you.
Thanks, Joseph. Great tool. Seems really interesting. So we have a question from MLG. Sorry, bro. That's a great thing. I like to use Deno than Node, but there are not many libs from Deno. So my question: is it able, or will be able, to convert big library like Electron or Puppeteer? That's a really huge one.
Yeah, there is no reason why it shouldn't be able to do so, but there is a lot of work ahead. It needs support for require. It doesn't have support for require. It needs a bundler to load local files. So I won't go too much into technical points, technical details, but in theory, yes, but in practice, it might require some time before it gets there. And the first priority is to get the full Node built-in support before anything more fancy.
Seems logic, right? Yep. Okay, so let's wait for a couple of seconds just to see if another attendee have a question. No. Okay, so maybe we can just finish the meetup here. So thank you guys for your talks, and thank you also for all the people who attend up. What is the roadmap to support libraries? So
what is the what?
What is the roadmap to support libraries?
I wrote a very detailed guide on the main repo. You can check it out. It's garrone.g.denoify. But if you type Denoify, you will find it. And it have very step-by-step guide and practical example on real libraries on how to support your stuff. I can't detail it right now because of time, but I think that if you read the documentation, you will manage to do it.
Maybe you can share that on Meetup in the comments
sure.
after the presentation, so we can retrieve the links. Could be a good option.
Okay.
Or share that on the chat, but because we are closing the stream, so probably the best option is to put that on Meetup inside the comment section. Okay, thanks again, Joseph, and thank you, everybody.
Thanks to you. Thanks to you.
Thank you very much. Yes, everyone. Thank you, Sylvain, for the MC part.
You're welcome.
And don't hesitate to come back to us for any type of suggestion about the stream, about the way we speak English, about I don't know, about anything. We want and we need to improve. If you want to help us on the website, on the organization of the meetup, on the next, we don't know if the next will be online or physical. It will be in 2 months, that's sure. But we don't know if it will be online or physical. But if you want to participate, come to us. Ask Sylvain or I, and we'll be more pleased.
It'll be a pleasure for us.
Yes. Okay.
Thank you, everybody, and have a nice night.
Bye, everyone.
See
Thank
you
you.
later.
Bye.
Bye, everyone.